So this is problem number 3 in proportional reasoning. And so the current through, the current through a circuit is 4A. And the resistance, which we'll highlight in yellow, is 6 ohms. And now we're going to write 4A in our table here because that's what was given to us. And then the resistance of 6 ohms. And here we're keeping the same battery. So that means that the coefficient is going to be 1. So times 1 means the same. And now we're going to see what the unknown is, which is what will the current be? So our final answer in the new value needs to be about the current. Okay, if the resistance decreases to 3 ohms. Right. And so we'll write that here in our table. So let's think about what this means. Okay, so we have 6 ohms times something is going to give us 3 ohms. Now, I know that 6 ohms divided by 2 is going to give me 3 ohms, but here we're looking at multiplying. So let's take this divide by 2 and multiply by the reciprocal of 1/2. Okay, and then that should give us 1/2 as our coefficient in our table. So I'll write that down in the blanks, 1 for voltage and 1/2 for R. Now we're going to try and figure out what the current coefficient is. And so we have 1 is equal to something times 1/2. And what is that something going to be? Well, I know that if I multiply by the reciprocal, I'm always going to get 1. So it must be 2 over 1, which means that 1 is equal to 1/2 times, or divide by 2, right? And so then, not times 2. Well, anyway, the unknown value here is going to end up being 2. And so 2 over 1 is the same thing as 2, which is going to be the coefficient for our current. And that part is the unknown, which we'll highlight over here in the table in green. And so we're solving for the current. So everything's going to be about the current. 2 is our coefficient, which we solved earlier. And so 2 times I, which is current, is equal to 2 times the original value of 4A, which we got from the problem and which we wrote down here in the table. And 2 times 4A is going to be 8 amps. So for the written description, if the same battery and the resistance is halved, the current will have to be doubled. And so that is it for this problem.